Okay, in Chapter 11 we're going to look in greater depth at how one controls for a confounding variable, and look in greater depth also at issues related to cause. Well, as you know, a confounding variable is a variable that affects the pattern of relationship between two other variables. Now, basically and pragmatically speaking, for a variable to be a confounding variable, that is, for it to have a substantial effect on the size of relationship or pattern of relationship between two other variables, it's got to be associated with both variables in this other relationship. So let's go to the special needs adoption study and look at an example involving a possible confounding variable. So an outcome variable in the special needs adoption study was the impact of the adoption as perceived by the adoptive parent responding to the survey of the impact of the adoption on the family. So that 58% of responding parents in minority families, that is, where at least one parent was of minority ethnicity and where the adopted child was of the same ethnicity as a minority adopting parent. In minority families, 58% of responses were very positive. In white families that adopted white children, 41% of respondents responded very positive. Hence, there was indeed relationship between the impact on the family and family ethnicity. I mean, this is because the percentages did indeed differ. I mean, what is the size of the association that we're looking at here? Let's go ahead and use our straightforward workhorse measure of size of association, the difference in percentages, and it calculates to 17%. So this is, in essence, a medium-sized association. So is this relationship a causal one? In other words, does some characteristic of minority families actually cause more positive impact? Or, on the other hand, is the relationship due to a confounding variable? I mean, is there perhaps, for instance, some characteristic of the kids adopted into minority families that differs from kids adopted into white families? And this factor, not ethnicity per se, explains the relationship that we've seen. So, in hunting for a confounding variable, we're hunting for a variable that's associated with both variables involved in the initial relationship, so with both ethnicity and impact. Let's look at the child's age at their entry into the adoptive home. Age at entry into the adoptive home is associated with impact, so that among kids who were younger than 6 when they entered the home, 54% of parents responded very positive. On the other hand, for kids aged 6 and older, percentage responding very positive was 37%. So there is indeed a relationship of age at entry with impact on the family. Is age at entry also associated with ethnicity? Yes, it is. In white families, 48% of the children entered when they were 6 years of age or older, whereas in minority families, only 34% entered at age 6 or older. So therefore, age at entry into the home is indeed associated with both variables in the initial relationship, with both ethnicity and impact. And because of this, it has the potential, and indeed to some degree is, functioning as a confounding variable. To some degree, it's affecting, in essence, the size of the relationship between ethnicity and impact. So what we want to do is we want to control for age, and having controlled for age, we want to look within the age subgroups that we set up and see whether within age subgroups we still see a difference in family impact. In other words, for kids, all of whom are the same age, do we still see more positive results for minority families? So let's talk through some of the logic of controlling for a confounding variable. So in our example, we're going to set up 5 age groups. Now, within each age group, age is very nearly a constant, which is to say, it varies hardly at all. In other words, within each subgroup, all of the kids are going to have entered their homes at similar ages. So within each age subgroup, you can think of age as nearly being a constant. And as we talked about a little bit in Chapter 6, a constant cannot have a relationship with another variable. So within subgroups, age cannot be a confounding variable. Within each subgroup, age can't affect the relationship of ethnicity and impact. This is because all kids are the same age. So we know, in essence, we're getting a fair comparison. Know that we're not going to see a difference in minority and white outcomes that's due to age, because within our age subgroups, all kids are the same age. We are holding age constant. So let's look at our results when we control for age at entry. And I just will mention a caveat that this is real data. And because it is real data, things will be complicated, and I won't be able to describe them quite so easily as I could in a contrived example. Real data have a way of not wanting to perfectly fit models. Now, I think that the big pattern that I'd point out here is that following control for age group, within most age groups, and for the most part, we still do indeed see association between ethnicity and impact. So let's, for instance, look at the kids in the 3 to 5-year-old group. So we know age is not biasing the minority white comparison much here, because all kids are very nearly the same age. And we're seeing 55% of minority families, but only 39% of white families reporting very positive. So within this group, we've still got difference. We've still got relationship. What about in the 6 to 8-year-old group? Again, the same thing. Actually, even a larger difference in percentages, a difference in percentages of 26% here, 62% versus 36%. And in the 9 to 11-year-old group, again, the pattern is for a higher percentage of minority families to respond very positive. We see that very same pattern here in the 12 years and older group. Though I do want to caution you that the frequency of minority families adopting children 12 and older is only 4. And when you get very low frequencies like this, you want to be tentative and cautious in your conclusions. Now one age group does show results that differ some from the patterns that we've just been seeing, and that is in the birth to 2-year-old group, the percentage difference here is quite small, only, as you can see, 3%. So, This top part of this slide summarizes what we've just been talking about. Within the subgroups, basically we're still seeing minority families reporting very positive impacts more often. Now, here's some rough math. I mean, this is not a formal procedure, but this is a kind of a pragmatic way that you might examine this data. So prior to control, which is to say for the full sample, the difference in percentages calculated to 58% versus 41%, or a difference of 17 percentage points. Minority families more likely to respond very positive. Now, subsequent to control, that is within each subgroup, I calculated the average difference in percentages. So for instance, here's the 3 to 5-year-old group, and for this group the difference in percentages was 16%. So the average difference in percentages across all 5 groups came to 14% following control for age at entry. So 14% is indeed indicative of smaller relationship than is 17%, though obviously just barely so. Using this average difference in percentages as a rough barometer, it does appear that within the subgroups, on balance, the relationship of family, ethnicity, and impact has weakened, but by just the smallest of amounts. So interpreting this data, because the relationship is weaker within the subgroups than in the full sample, what we would conclude is that the association between ethnicity and impact is partially due to the confounding variable age at entry. Yet on the other hand, 14% is only a little smaller than is 17%. So on balance, we can say within the subgroups, the relationship of ethnicity and impact, it remains intact. And clearly in this example, the larger part of the association, so to speak, the 14% versus the 3%, the larger part of the association is not due to age at entry. So, the relationship between ethnicity and impact did not disappear when we controlled for age at entry. This being so, we hold open the possibility that this relationship might be a causal one. On the other hand, we have not controlled for all possible confounding variables, and as such we cannot conclude that the relationship is causal. Now, our adoption study is a non-randomized design. I mean, it's a survey. Now, in any non-randomized design, it is in essence impossible to think of all possible confounding variables. So that therefore, in essence, one could never control for all confounding variables. So, I mean, this is an example of how one begins the process of controlling for confounding variables. And indeed, we can introduce second, third, and fourth confounding variables, and then look at relationship with all of these variables held constant. And indeed, at the end of this text, we'll get to multivariate analysis, which doesn't control for confounding variables with tables, but instead with multivariate statistical tools. But even so, this basic message stands that in the survey design and other non-randomized designs, the best we're going to be able to do is to control for pragmatic confounding variables that we can think of ahead of time and therefore measure. Now, I should just point out again, with random assignment, there are no confounding variables, and obviously one can have much greater confidence regarding causality. Common sense. Stop and think for a minute. Could one ethically carry out a study in which children were randomly assigned to adoptive families? Probably not. Kids are going to go to families based on things like the needs of the kids, the desires of the families, whether the kids are relatives to the adoptive family would be an important factor. So I think it's safe to say that one could never carry out such a study involving random assignment. That being so, in this particular area, we're not going to reach definitive conclusions about causality. So if we see some areas in which one group of minority kids, a group of minority kids does better, or kids in a different age range or with different characteristics, we're going to be able to draw, educated, solid, reasoned conclusions, but we're never going to get to that strong causality that comes from randomized studies. So let's go ahead and talk more about control for confounding variables. Now, this is a partial list, but some of the key patterns that you might see when you control for a confounding variable are that within the subgroups, the association persists, which is to say that within the subgroups, the size of association is very nearly the same as was the case prior to control. Now, one could argue that that's the pattern that we saw in our adoption example because the size of association decreased by such a small amount. Now, another pattern that you often see is that within the subgroups, the association weakens, but nevertheless continues to be there. Within the subgroups, the size of association is considerably smaller than was the case prior to control. So, and this is the situation where, in essence, the controlled for variable is a partial reason for the relationship that's observed. And then a third pattern that you see is that within the subgroups, the relationship disappears. Now, if you think back to Chapter 10, in that example, that involved type of placement, foster versus group, and behavior problems, we saw the relationships disappear within the age groups. And basically, when you see this pattern, the relationships disappearing within subgroups, that's the situation where the relationship is due to and caused by the confounding variable, the controlled for variable. And a fourth pattern is for the size of association to differ markedly in the different subgroups. And to some degree, we saw this pattern in our adoption example, in particular in the 0 to 2-year-old at entry age group. The minority white difference was only 3%, and this was much, much smaller than was the size of difference in the other age groups. So what we want to do now is pursue some examples that show you these different patterns. So let's in essence treat that option example as our association persists pattern. It was pretty close to that pattern. So when the association remains the same size in the subgroups as in the full sample, your basic conclusion is that the initial association is not due to the controlled for variable. You conclude that the control for variable did not affect the size of association, and that controlled for, indeed the controlled for variable in this case is not actually a confounding variable, in the sense that the definition of a confounding variable is a variable that affects the pattern of association between two others. And if the pattern of association isn't affected, in other words, if the relationship is the same size, subsequent to control, then indeed the variable isn't a confounding variable. And now then, what conclusion would you reach about causality? And I'm presuming, again, we do not have a randomized design. So the idea is, in this situation, the relationship may be causal. I mean, in particular, you know the relationship is not due to the controlled for variable. But on the other hand, the relationship might not be causal. It might be due to a variable that is not controlled for. So here's some hypothetical data demonstrating the association weakens pattern. And so, I mean, let's presume that the initial difference was indeed that 17%. So let's just quickly eyeball these differences here. I mean, here's a difference of 4% in the youngest age group. This is a difference of 9% in the 3 to 5. Here's 13%. In the 9 to 11, our difference is 5%. And here in the 12 and older, it is 11%. So these differences are, on balance and average, considerably smaller than the 17% difference in the full sample. So, I mean, it works out to be the case that the average difference in percentages is 8% in the subgroups. So let me just reason in a pragmatic and even informal way for you on this. Well, the difference between 17% and 8%, that is 9%. Well, that's the difference that's disappeared subsequent to control. So that part of the difference, or that part of the relationship, is in essence due to the controlled for variable. So age is in essence responsible for 9%, a little more than half of the size of the initial association. So this relationship that we're seeing between family ethnicity and impact here is partially due to age. Yet on the other hand, the relationship hasn't disappeared. The average difference is not 0%, it's 8%. So the part of the relationship that's remaining intact, this 8%, we can conclude it is not due to the controlled for variable age. So thus this part of the relationship, I mean, it may be due to an uncontrolled for variable. In other words, there's really a limitless number of other variables that we might seek to control for. So we can't conclude definitively that the relationship is causal. But on the other hand, this part of the relationship, it may be, it could possibly be causal. In essence, we'll never know. We know that this part of the relationship isn't due to age, but beyond that, we can't be sure about causality. And this slide presents some more of the ideas I was just speaking to. The control for variable is partially responsible for the initial relationship. Some part of the initial relationship may be causal. The controlled for variable isn't fully responsible for the initial relationship. It's partially responsible. So, I mean, we're shifting substantive areas here now to present the association disappears. Pattern. We have a situation where, in a college environment, the mean GPA of those who use marijuana is 2.5. The mean GPA of those who do not use marijuana is 3.0. So, is marijuana causing lowered GPA? So one thing that we might want to do is control for other variables that could potentially be associated with both GPA use and marijuana. So let's go ahead and control for level of motivation in school. So let's hold level of motivation in school constant, and let's, within subgroups of motivation, examine the relationship of marijuana use and GPA. So let's look at the 4 different groups. And you can see that both among those who use marijuana and those who do not, level of motivation is associated with GPA. So you can see that those in the very high motivation group, for instance, have the highest GPAs. But our key comparisons are those within the motivation subgroups. And I mean, I tried to make this look like real data by creating some differences. But I mean, the gist of the matter is that GPAs are, in essence, very nearly the same among marijuana users and non-users. And this is the case within each of these four groups. Or in other words, these differences are very, very small within the motivation groups. So what conclusions do you draw when the relationship disappears within the subgroups, as is the case here? I'm going to talk about the basic conclusions that one draws, but then mention that the situation is more complex. Sticking with our basic logic that we've been using in the last chapter and this one, when a relationship disappears, the basic conclusion is that the initial relationship is not a causal one, but that the initial relationship is due to the controlled for variable. So in this example, our conclusion would be that the initial association between marijuana use and GPA, the differing GPAs of users and non-users, we would conclude that that association was not causal, but rather instead that association was due to and brought about by and is explained by motivation level. So when we do not control for motivation level, we've got relationship. When we do control for motivation level, relationship disappears. So our basic conclusion is that this initial relationship, this relationship between marijuana use and GPA, is due to motivation. The situation, however, is a bit more complex than this, and so the next video is going to introduce causal models and some of the complexities some additional complexities involved in reaching causal conclusions.